Good evening, this is Kavipriya, Assistant Professor, EEC Department. Today I am going to deliver a topic, Linear Variable Differential Transformer. So LVDT or Linear Variable Differential Transformer is most widely used inductive transducer that converts a linear motion into electrical signal. So it consists of a primary and secondary winding. Through the primary winding input voltage is applied and the output voltage is measured across a secondary winding. So a transformer consists of a primary winding and two secondary winding which is wound on the cylindrical former. So both the secondary winding have equal number of turns and we place them on either side of the primary winding. The primary winding is connected to the AC source which produces a flux in the air gap and voltages are induced in the secondary winding. A movable soft iron core is placed inside the former and displacement to be measured is connected to the iron core. The LVDT is placed inside the stainless steel housing because it will provide electrostatic and electromagnetic shielding. Both the secondary winding are connected in such a way that the resultant output is difference between the voltages of two windings. And next is the working principle behind the LVDT. As a primary is connected to the AC source, so the alternating current and voltages are produced in the secondary of the LVDT. The output in secondary is S1 is given by E1 and the secondary S2 is given by E2. So the differential output is E1 minus E2. We have three cases to be considered in the operation of LVDT. The first case is when core is at null position and there is no displacement. When core is at null position, the flux linking with both the secondary windings will be equal to the induced EMF, which is equal in both the winding. So since there is no displacement, the output E out is 0. Since E1 and E2 will be same, the E1 minus E2 is nothing but since both are same, E1 minus E2 is 0. So E out is 0. It shows that there is no displacement took place. Second case is when core is moved in a upward of a null position. So in this case, the flux linking with the secondary winding S1 is more as compared to the flux linking with the secondary winding S2. So E1 will be more as that of the E2. So due to this, E out is nothing but E1 minus E2. Since E1 is more, E out is considered as a positive. In category 3, case 3, when core is moved in a downward position. So in this cases, the magnitude of E2 will be more when compared to the magnitude of E1. So E out is E1 minus E2. Since E2 is more, E out is will be negative. The amount of change in voltage can be either negative or positive as proportional to the amount of the movement of core and it indicates the linear motion. So by noting the output voltage increase or decreasing, the direction of motion can be determined. The output voltage of LVDT is a linear function of a core displacement. So the motion is in turn converted into the voltage. And advantages of LVDT is it is of high range. LVDT is a very high range of measurement of displacement. They can be used for measurement of displacement ranging from 1.25 millimeter to 250 millimeter, and there is no frictional losses as a core moves inside the hollow former, so there is no loss of displacement input as a friction losses, so it makes LVDT as very accurate device. Third is a high input and high sensitivity. Output of LVDT is so high, it does not need any amplification at all. The transducer produces a high sensitivity which is typically about 40 volt per millimeter. And next is a low hysteresis. LVDT show a low hysteresis and the repeatability is excellent under all conditions. And next is a low power consumption. The power consumption is about 1 watt, which is very small as compared to other transducer. And next is a direct conversion to the electrical signal. The displacement here is directly converted to electric voltage, which are very easy to process. And next is a drawback. It is sensitive to stray magnetic field, so it always require a setup to protect them from a stray magnetic field, and also it get affected by vibrations and temperature. And next is applications of LVDT. We use LVDT in application where displacement to be measured are ranging from fraction of few millimeter to few centimeters. LVDT acting as a primary transducer converts a displacement to electric signal directly. LVDT also act as a secondary transducer. Bore-bond tube, which act as a primary transducer, it converts the pressure into linear displacement, and then LVDT converts the displacement into electrical signal, which after calibration gives a reading of the pressure of fluid. It measures the fluid levels, inspect lines and power turbines. So that's all about the construction, working principle and advantages and drawbacks of LVDT and applications of LVDT. Thank you.